Nature is multidimensional. The more you explore, the more you see. It is quite a public knowledge. Derivatives are particularly fascinating for the ways in which they could be explored in any situation. And in some situations, derivatives can reveal extensive complexity. This case study focuses on earthquakes, one of the most expansive, sweeping, and swift natural phenomena. It is a straightforward yet educative example in the context of multiple rates of change, measuring the rate of change with respect to various dimensions, changing simultaneously. Earthquakes can be studied through many kinds of rate of change, because their rate affects everything on Earth, including triggering tsunamis along coastlines. Earth. The basics. The outer layer of the Earth, known as the crust or lithosphere, is broken into several large and numerous smaller pieces called tectonic plates. Tectonic plates move due to the convective currents in the Earth's mantle, driven by heat from the Earth's core. Gentle interactions between tectonic plates result in geological phenomena such as mountain formation and ocean basin creation. Unexpected interactions can lead to earthquakes and volcanic eruptions. Understanding earthquake. When the tectonic plates move and interact with each other, stress is generated along their boundaries. Stress is the force of compression or shear, the force that deforms, acts on rocks and matter that make up the Earth's crust and upper mantle. Over time, stress accumulates until it surpasses the strength of the rocks, eventually causing them to fracture along a line of weakness known as a fault. Once the fault ruptures, rocks on either side move relative to each other, releasing powerful waves in the form of an earthquake. The seismic waves. The vibrations, in the form of mechanical waves, are similar to the ripples created in a pond on throwing a stone. They spread out in all directions. Mechanical waves require a medium to propagate. In the case of earthquakes, the medium is the Earth's surface and subsurface layers, specifically the crust and mantle. These waves are known as seismic waves. The literal meaning is shaking waves. These waves are responsible for the shaking and ground motion experienced during an earthquake. Seismic waves with different velocities. Earth's crust is composed of various rock types, and the mantle consists mostly of solid rock, but it is partially molten in some regions due to the high temperatures and pressures at these depths. Seismic waves travel at different velocities through Earth's crust and mantle because the speed of mechanical waves depends on the properties of the medium, such as density, elasticity, temperature, and viscosity, through which they propagate, as well as the frequency of those waves. The velocity of seismic waves can be estimated by analyzing the frequency and amplitudes of the various waves, recorded by seismometers located at different distances from the earthquake's epicenter. Analysis of stress and seismic waves. By understanding how stress accumulates and is released in the Earth's crust through seismic activity, scientists and engineers can better predict where and when earthquakes are likely to occur. By studying how seismic waves propagate through the Earth's interior, scientists can gain insights into the Earth's structure and composition, as well as the processes that drive geological activity. Velocity derivative of seismic waves. In seismology, mathematical tools are essential for analyzing seismic waves, and velocity derivatives are one such tool. The velocity of seismic waves is not constant over time, but varies depending on the properties of the Earth's crust and mantle through which they propagate. Instead of expressing the velocity derivative only with respect to time, seismologists also express it with respect to distance, depth, or frequency. This is the more relevant part, derivatives that are not just with respect to time. Common velocity derivatives. Velocity gradient is a derivative of velocity with respect to distance. In seismology, it measures how the velocity of seismic waves changes with depth in the Earth's crust and mantle. Velocity dispersion measures the spread or variation of velocities within a system. In seismology, it is a derivative which shows how the velocity of seismic waves varies with frequency. Attenuation measures the decrease in the amplitude or intensity of a wave as it travels through a medium. It is a function of distance or time. Thus, it is another type of velocity derivative which involves rates of change with respect to increasing distance on the Earth's crust from the earthquake source or with respect to time lapse from the start of waves. Importance of velocity derivatives. Velocity derivatives of seismic waves are crucial in seismology because they provide detailed information about the structure and composition of the Earth, such as the thickness and structure of the Earth's crust or the density and elasticity of the Earth's mantle. By studying earthquakes, we can better understand seismic wave velocities and their relation to the geomorphology, the study of the Earth's surface features of various regions. Instantaneous values of seismic waves. Seismic waves are typically recorded as a continuous time series of ground motion measurements, which can include displacement, velocity, or acceleration. The instantaneous values of seismic waves refer to the specific values of ground motion at a particular moment during the recording of the seismic signal. Instantaneous values of seismic waves have a meaning of their own, and it is understandable. Importance of instantaneous values. The instantaneous values of seismic waves are important for understanding the properties of the seismic signal, such as its amplitude, frequency content, and timing at a specific location. These values are essential for measuring and predicting future losses of life and property. They contribute to the development of earthquake-resistant building codes. They are vital for the implementation of early warning systems. Thank you. With us, you will master all the mathematics you need. Be good to you, not just others.